In this video, we'll review how to graph exponential functions. To begin, let's make sure we remember what an exponential function is. We have an example g of x equals 2 times 3 to the x. In an exponential function, we'll begin by recognizing it's exponential if the exponent is the variable. In this problem, 2 is the initial value. 3 is the multiplier. And because the exponent is just x, I know that the zeroth term is 2. So this tells me that f of 0 is 2, and every term after that we're going to be multiplying by 3. So we're going to go, the zeroth term is 2, and then 2 times 3, and then 2 times 3 times 3, and then 2 times 3 times 3 times 3, and so on. Now if this was an x minus 1 up top, that would tell me that the first term was 2, and every term after the first term is where we start multiplying by 3. So if you just see the exponent as x, it's best to start with the zeroth case, and that's that initial value. But if it's something else, like x minus 1 or x minus 2, then you're going to start on that term with the initial value. So let's look at how to do this. As I said just a moment ago, because we have 2 times 3 to the x, and it's just x, we know that the zeroth term is 2. Now you can also do this by substitution. If you go 2 times 3 to the zeroth, 3 to the zeroth is just 1, and then 2 times 1 is 2. Because now we're multiplying by 3's, 2 times 3 is 6, or again using substitution, 2 times 3 to the first power, well 3 to the first power is 3, 2 times 3 is 6. Multiplying by 3 again, and 3 again, and 3 again. Or, again, we could use substitution. To graph this, the x's are on the bottom, so we've got to scale out from 0 to 4, and vertically, I've got to go from as low as 2 to as high as 162. So I'm going to go ahead and count by tens. Now some of these points aren't going to be real clean, but it'll get the point across. When x is 0, y is 2. Well, 0, 2 would be located down here, just above the origin. And then 1 is 6, 2 is 18, 3 is 54, and 4 is 162. Now when I graph an exponential, I should see that it makes a curve. And it's going to be a curve with a constant factor. Every point in this case is 3 times as high as the one that came before it. It's 3 times as high because that's my constant factor. In 2 times 3 to the x, we're constantly multiplying by 3's. In the second problem, we have the equation f of x equals 16 times 1/2 to the x. Take a moment and figure out what term would be 16. Alright, hopefully you said the initial value, the 16, is going to be the zeroth term. I know it's the zeroth term because we have 16 times 1/2 to just x. It's not x minus 1 or anything else like that. If it's just to the x, I know the zeroth term is the initial value. In this case, the constant factor is 1/2, so to find each number after that, we're going to multiply the previous term by half. So 16 times half, or half of 16 is 8, half of 8 is 4, half of 4 is 2, and half of 2 is 1. Again, I could do these by substitution. For instance, if I was going to find what f of 2 is, I would go 16 times half raised to the 2 power. Well, half squared would be 1 squared over 2 squared, which is 1/4. 16 times 1/4 is 4. Now we'll plot those points. So 0, 16 is the beginning term, so that point is here. And then it's 1, 8, 2, 4, 3, 2, 4, 1. This time the curve is decreasing. So I'll draw it in, and it's going to look like this. Again, it's curved. In this case, the curve is going to flatten out right above 0 for the y equals 0, so it'll never actually hit the x-axis. This time the constant factor is 1/2, which means each point after the original one is half the height of the original point. Now let's look at one more. Here's an example where it's not with an exponent of just x. We have y equals 5 times 2 to the x minus 1. Now this x minus 1 tells me something important. It tells me that the first term is 5. And every term after the first term is where we're going to start multiplying by 2's. So if I use the same kind of numbers in my table from 0 to 4, I'm not going to start with using 0, because if I was going to do this without a calculator, I would say, you know what, I know the first term. Because it's to the x minus 1 exponent, I know the first term is that initial value of 5. Every term after that, we're using a constant factor of 2, so I can find those by just saying, well, the next one's 5 times 2, that's 10, and then 10 times 2, 20, and then 20 times 2, 40. To go backwards and find the 0th term or the negative first term or the negative second, I'll do the opposite of multiplying by 2, which is divide by 2. So if I know the first term is 5, divide that by 2, and you get either 2.5 or 5/2. And now I'm ready to plot these. I'm going to set up my graph, and I'll plot my points. 0, 5/2 or 0, 2.5 would be there. This time I counted by 2.5, so I said every other square is 5, so that 2.5 would be in between. 1, 5 would be my next point. That point is twice as high as the original because, again, we have a constant factor of 2. The next one is 2, 10, which is, again, going to be twice as high as the 5, and so on. Again, it will be curved. This one will be increasing like the first one was, and it's going to flatten out right above y equals 0. It'll never hit the x-axis. So the graph should look like this. All right, I hope this short video helped you to understand how to graph exponential functions, and thank you for watching.